Okay, welcome back to the part 2 of the Human Resource Data Science project. And in this section now, we want to compare if the average monthly hours, the number of projects, and the time spent in the company of the exiting employees is actually higher or lower than that one of the remaining employees. And that will give us information on why possibly these people or these employees have left, and that is very, very instrumental in answering the business question, what type of employees are leaving and possibly why the employees are leaving, so that the business is aware that these are the decisions that might have caused the employees to leave. So already we have got the data set, or we have got the data frame for the exiting employees, which is DF, the one that we imported previously. If you have not checked it, please watch it on the part 2. But it's DF head. This is the data set for the leaving employees. I want us now to import the data set for the existing employees, which is this spreadsheet here. So the name of the spreadsheet is existing employees. So to do that, let's import it as a, let me just import it here because we already know we have got DF, which is that of the exiting employees. But this for the existing employees, let's call it df1, and we're going to use pdsym read excel and give it a name. The name of our data set is still the same. This is our data set. The only thing that is changing is the sheet number. So let's just copy the sheet number from the data itself. So that one will just import the data set for those employees who are still with the company. And let's make sure that we have imported the data correctly by displaying the first 5 data points. And yes, we have got our first data points. Let's try and explore this data and see how many employees are still with the company. By just doing shape, it will tell us the number of employees. So you can see, no, it's df1, sorry. So you can see the number of employees with the company is 11,428. So this is a very, very big organization. Probably is a global organization employing thousands of people. So now the key, or our task here, is to compare the average number or average monthly hours of the employees who have exited and the average monthly hours of employees who are still with the company, and see that for those who have exited, is it true that those who have exited have been working more hours in a month or less hours in a month? And that will be very, very important in trying to understand the problem, why they have left, and what kind of employees are likely to leave next. So to do that, we're going to calculate the average number for the mean number for monthly hours, time spent, and number of projects. So let me just enumerate that in terms of titles. So let's make this heading. So the first one is average or time spent in the company. So to do that, let's have these 2 data frames or 2 calculations. So let's start with df exit employees. So these are employees who have exited, and remember it was df. It was let me start with those who are still there, existing. So df exist, so for employees who are still with the company, and this is df1. And then remember to calculate the mean of a column section. So we're going to calculate the mean of this column here, this column called time spent for employees who are exiting. So that is for this data frame df1. And then we're going to do the same for df, which is for the employees who have already left the company. So we can do that by specifying the column name. I'm just going to copy the column name straight away, paste it over there. And to calculate mean is very simple. In data frame, I showed you in my previous tutorials. So it's just use mean and then brackets. So this will tell us the mean of employees, or the time spent by the employees who are still with the company. And then let's also do the same for employees who have exited the company, which is defined by data frame 1, not data frame 1, but just df. And then it's the same thing. Can literally copy this. The only thing is the name of the data frame changes. It's df. And then let's print the two side by side. And I want us to use a clever way of printing this so that they're side by side. You can refer which number belongs to the exiting and which one belongs to the existing employees. So I'm going to print this, say existing. So the mean for existing employee is going to be assigned to variable df. So let me just print this. So I can print the two side by side here. This is the mean average hours worked by existing employees. And then this one is that worked by exiting employees. So if you print, you quickly realize that the employees who are still with the company worked an average monthly hour of, not hour, but time. The average monthly time spent with the company for those employees who are still there is 3.38. And those who have left have spent less time with the company, 3.87. So that's kind of makes sense according to a hypothesis. So to make these figures be much interpretable, we can add a series of key strings here to define so that it shows the reader what this means. So let me just do that in Python. I'll say existing. So this is a string. Employees are this. So you basically add this curly brackets, and that curly brackets, whatever is going to be inside here will be this number that you have calculated. And then we do the same, and exiting are another curly bracket again. What we are going to have here is going to be this number for the exiting employees, and then we can feed those numbers automatically by using the function called format, and then specify the variables that are going here and here in the chronological order. So we're going to start with this one, which is df exist, the mean of the existing employees, comma, and then that of the exiting employees, and then print it so that it's side by side. So now the exiting employees is 3.38. Basically, I've just added words to help define these numbers without trying to struggle with which one is representing the exiting and which one is representing the existing employees. So the existing employees have spent an average time of 3.38 years in the company, while those who have left have spent a time of 3.87 years in the company. So we can confidently say in our report here that exiting employees have spent less time in the company compared to the existing. So the question is, why have they left? Because your boss is really interested in this. So let's go on with our analysis. So we are done with time spent in the company. Let's see if the average monthly hours is going to help us. So I'm just going to copy the heading to be consistent, and then change this to heading, of course. This is going to be B, and it represents the average monthly hours. So this is the average hours that we're going to compare the average monthly hours that the exiting employees and those who are still with the company have spent. So it's the same thing. Let's just copy this code here, but now we're going to change our column name to average monthly hours. So let me copy the column name. It's very straightforward. Okay, run it. So you can see that the existing employees have spent 199, an average of 199 hours in a month, while those who have exited have spent an average of 207 hours in a month. So this is very, very unfair. Those people who have left have been working more hours than those who are still with the company. And these are some of the things that your bosses will be interested, and they'll be curious that how did this happen. So possibly it's easy to tell, or it's very convenient to say that those who have left, maybe they felt that they were overworking and they were not being paid well. So let's hypothesize why these people have left. Remember, this is all depends with the whatever you have reported as a data scientist, unless you have a domain in the field. If you're a human resource, then probably you will tell exactly that this is it. But if you're just a data scientist from a different background, then you just hypothesize and maybe ask those who have experience to tell you why this is happening, because you have got the data, but you don't know what they mean in the context of work. So we can say exiting, let's hypothesize, exiting employees. First of all, just summarize whatever we have done. Spent more, average monthly, in the company than the existing ones. Possible explanation. This is a comma, question mark. I will say not. So these are just hypotheses. Appreciated, hence they left. Or another option or another alternative. So this is where now thinking comes in, and also your previous experience with the data or previous knowledge domain. I can say it might just be because they worked in crucial. So what I'm saying is, maybe majority of the employees who have exited are employees who are working in the production line, or maybe they are salesperson, meaning that they are involved in a lot of, or the core business of the company. So they are likely to spend more hours than maybe somebody who is just a human resource in the company, or somebody who maybe is a manager. So it depends, or maybe somebody who is the company attorney. So those are likely to spend less hours, but those who are working on core production line, they're likely to spend more hours. So that could be another explanation. So that's why I'm just postulating here that worked in the crucial departments that are central to the organizations on the company's core mandate. Or maybe these people might have worked a long time and they have acquired skills, and maybe they have just moved to a new company. So I'll say let's say maybe if they were interns, if they were, but they are employees, so that doesn't add up. So let's say they might have acquired more experience, hence left for other lucrative. So this is just a hypothesis. So by the virtue that they have worked 207 hours more than the existing employees, then chances are that maybe they have been working more hours to get experience, and once they have that experience, they can show it on their CV and use that to knock doors or new doors that offer more promising opportunities. So that's my hypothesis for that. So now let's go to the last part of it. Let's compare now the working or the number of projects, the average number of projects that the employees who have left have worked on, compared to those who are still with the company. So again, let's just copy this straightforward instead of typing. Though it's a bad practice, it's always good to type the code, especially if you're on the learning phase. But for the purpose of time in this video, I'm just going to copy it. Feel free to type it, as you are more likely to understand when typing rather than copy pasting this. So let's see the comparison. Again, this is weird. The employees who are still with the company have worked an average of 3.8 projects, while the employees who have left have worked slightly more projects than those who are there. So I think this organization is not fair. The ones who have left have been working more hours, an average monthly hours. The ones who have left now, we can see from the data that they have worked an average of more number of projects compared to those that the company has retained. And I think this is something that maybe it's very inherent in most or in some organizations. So we can say, let's summarize the results. Let's try to remain objective, not blame the organization. So let's say employees again, I'm making a very bold statement here, but I hope that I'm going to be vindicated later on by the data. But I think now we have clearly seen a pattern in the types of employees who have left and the employees that who have stayed based on this metric here, the evaluation. The last evaluation scores. So now we have obtained a lot of information by just using the correlation heat map, or simply using the Pearson's correlation coefficient to analyze the data. And this is how you kind of start developing those skills that will help you to tackle different projects or different problems in organization that you are working on, or on your work or your research work. Now, let's go to the next variable in our list. Is a comparison of the number of projects with all other variables. So if you look at the correlation between the number of projects and the promotion score in the last 5 years, it's between 0.032, is at negative 0.032. So no correlation, 0.01. The next one is 0.084, no correlation. We have got 0.6, that should be high correlation. So we can say there's a high correlation between the number of projects with the time spent in the company. So let's do that. And then before I do that, we can also say there is a strong correlation between the number of projects and the average monthly hours, which is 0.88. So again, that's a very strong correlation. And then we have got number of projects and last evaluation. If you remember well, we have already done that in our previous, so we don't need to rewrite this because it's here already. It's the number of projects against last evaluation. This one is still number of projects against last evaluation. So let's just write these two reports about the number of projects in relation to time spent with the company, and also the number of projects in relation to the average monthly hours. So this should be our third point now. Keep track of the points. But don't worry, I'm going to send this file to GitHub so that you can have a look at it. So let's write the report. There is a strong correlation. Is it really strong? So 0.6. 0.6 turns at there's a high correlation. So let's say no strong. There's a high correlation between the number of projects and time spent in the company. And then 2, there is a very high correlation between the number of projects and average monthly hours. And I think this is very logical. This is very much logical, because if you are having more number of projects or high number of projects, then it means you have more time working on that project, and therefore your average monthly hours is automatically likely to go up, and that's what's happening here. So if we do that, let me just space them to make sense, and then let's try to demystify what each of these mean. And I'm just doing this because it will help you as you revise through your code. So possibility are the higher projects, the more the average monthly hours. Again, the lower the number of projects, the less the average monthly. That is in as far as number of projects is concerned with average monthly hours. And then the next one is time spent. So we can say the higher the number of projects, the more the time, the more the average monthly hours. And the opposite is true. So the lower the number of projects, the less the number of monthly hours. Okay, so let's go to the next set of the correlation, average monthly hours. The only interesting bit here is 0.66 time spent in the company with the average monthly hours. Because it's 0.6, these ones are less than 0, so there's no correlation. 1, of course, that's correlation. And another one, 0.88, that is average monthly hours compared to number of projects, which we have done in the previous section. And again, average monthly hours 0.83 with the last evaluation. We already did this under last evaluation, so you don't need to repeat it twice. And then we have got negative 0.084, not very much significant. So we can only talk about this because the rest we have talked about them. So we can see there's a very 0.66 that falls between 0.5 and 0.7. So there's a high correlation between average monthly hours and the time spent with the company. So let's write that down. Okay, so what does this mean? This is just to help you with the interpretation. The more time spent the company, the higher the number, the higher average monthly hours. And the reverse is true, which is the less time spent with the company, the lower the average monthly hours. So probably in my case I will say more experience. So if you spend more time in the company, chances are that the management will trust you, and therefore they will assign you more tasks, and that means you will have got more average monthly hours, which they are not doing, by the way, because we clearly see that the employees that are still there have got less average monthly hours. So data is interesting. It tells you the story, and you can clearly see the story in this company. Something clearly is not right. So that is to do with the fourth observation in terms of average monthly hours. The next one is time spent. So you realize that we have already compared it with all the other variables, so we don't need to go back except for these small variables, which is not much interesting. So I don't think if it's worth looking at 0.0052 because that falls below no correlation threshold, so we don't care about that one. And now we come to the elephant in the room, the work accident. So if you look at work accident section, literally there's no correlation with the rest of the data set because it's less than 0.1 all through. Same to promotion in the last years. So if this was a project where you are developing a model that's gonna help you to maybe predict the next employee to leave, then you don't want to have this because they will just result in noise in your data because they are not contributing, they are not related to all other factors. But there's also the concept of collinearity, and that is something that maybe we look at later when we start getting our hands into model development. But for now, I think we can discard them. So in other words, what this data is telling us that the number of accidents in the company and the promotion in the last 5 years have very little to do with other features in this data set. So we can drop them, and let me just type it somewhere and copy it here for the essence of time. Let me type it on my notepad. Yeah, run it. So work accidents and promotion in the last 5 years has little correlation with other features. If this was a model development project or problem, we could have just dropped the column. Now, the two columns, work accident and promotion last years, are of interest since they contain several zeros. So if you look at the data set here, they have got zeros. So basically, they have zeros and ones. And the reason why they are having zeros and ones is because they are representing a category called feature, which is binary. So in this case, it's either yes or no. Have you had work accident? Yes or no. So instead of having yes or no, they are having values. So no, 0 to mean no, yes to mean somebody has had accident. Same to promotion column. They are having 0 and 1. So if you have promoted in the last 5 years, it's a 1. If you have not, it's 0. So that is what that data is doing. But let's try and see how many people have had accident in the company and how many people have not had accident in the company. And also look at how many people have been promoted in the company and how many people haven't been promoted in the company in the last 5 years, so that before we drop these columns or don't do anything much with them, we are sure that they are of less significant as far as other features are concerned in this data set. So we can do that. So let me just type somewhere our transition to why we are doing that, and then paste it here for the essence of time. Okay. And then zoom it. So now we can zoom into each of them and group them using the group by function as we discussed in our previous tutorial. So we learned about how we use group by function. So let's apply that technique here and group this data set based on that technique. So first of all, let us group the work accident using the group function. So let's create a variable name called df work accident for short, and then use df. We use the function group by. So this is part of pandas function or part of pandas library, and then select the column name, which is work accident. I normally prefer to copy them so that you don't miss any problem or don't miss any white space. And then we want to make sure that we return the size of that. And before return the size, we reset the columns or reset the index so that we don't run into index error with pandas. And I want us to name the new column work accidents. Remove the underscore. And then let us see what it has for us. So this function is going to go to this column here, work accident, and count the number of zeros and also count the number of ones and sum them up and then return them to me so that I can know that, okay, for zeros representing those who have had accident, this is the number. For those, those who have not had an accident. And then for ones representing those who have had accident in this organization or business, this is the number. And then we can do the comparison and know that, okay, these are the number of people with accidents, these are without. So that's what this code here is doing. So let's run it. It's taking a while. Oh, I've run into problem. Work accident does not match index name. Work accident. Interesting. Okay, so I need to specify a name here to show that I'm writing a new name of that index. So here you have the results. So 0, 3,402. So it means all out of the 3,571 employees, 3,402 have not had accident and 169 have had work accident. Let's do the same for, so before we do that, let me just write to help you with the comment. So from our analysis, only 169 out of 3,571 have had accident at work. And you can sometimes, this is just like a bonus, you can do a percentage to help you in writing the report. So you can say that 169 out of 3,571. So basically it's 4% or 4.7% of your employees had accident. So that is important if you're writing a report. We can do the same for promotion to see how many people have been promoted in the last 5 years and have left the company. So we just change this to, I'll say promotion, rename it to promotion, and then use this one. We have to use the original name of the data frame. Good. So for the employees who have left, 3,552 have not been promoted. No wonder they are leaving. And only 19 of those who have left have been promoted. So maybe these are what we call outliers in data science. So maybe these people have left for another reason. Maybe they got a well-paying job, or maybe they retired, or maybe something happened, a misfortune, maybe death. You never know. So those are outliers. But generally, you can see 3,552 people who have been or who have exited the company have never been promoted. So let's capture that down so that it can go to your report. So what does this tell us? Let me make it a markdown. So again, it strongly suggests that so remember, you are the person having this data, and therefore you can use whatever you're having to back up what you're saying, because your analysis is just telling a story. And this story is anchored on data that has been provided by the organization or the business. So now we can safely assume that we do away with the work accident and promotion in the last 5 years for further analysis. So now in the next section, we are going to see which category of this data is likely, or which category or which features are likely contributing to more exiting, or what is the dominant feature for the exiting employees. So we're going to look at how does the evaluation score affect this, how does it rank, how does the number of projects affect this, average monthly hours, time spent, department, and salary. So that is going to come up in the third section of this, our project. So if you like the video again, please feel free to give it a thumbs up like by typing or clicking the like button. Subscribe if you haven't. Share with friends who are interested in this kind of work. Tell a friend to tell a friend. Until next time, bye bye.